From the first moment a human child opens their eyes, they are already under the command of an unseen sculptor. Gravity, silent and tireless, presses against every cell, pulls on every drop of blood, and defines every step that life can take. It is not merely a force, not a simple downward tug measured by equations on a chalkboard. It is an architect that has shaped the form and rhythm of every living being on Earth. From the soft curve of a leaf bending toward the soil to the upright stance of a human spine, balancing under the weight of its own history, gravity has written its will into flesh and stone alike. The Earth's pull, measured as 9.8 meters per second squared, is the metronome of existence. Every heartbeat, every reflex, every bone density evolved under its unrelenting guidance. Muscles formed not to move freely through empty space, but to resist the fall. Skeletons hardened to withstand compression, while blood vessels learned to push upward against the endless pull downward. Even the brain, cradled in fluid, was tuned to expect a world with a single direction, down. Picture a human silhouette standing on the edge of a cliff. To the eye, the body seems still. Yet inside, trillions of cells are working to oppose the invisible sculptor. The muscles in the calves contract to keep balance. The spine aligns its vertebrae like pillars in a cathedral, and tiny sensors in the inner ear whisper constantly to the brain about which way is up. Gravity holds this living structure together, testing its endurance, demanding energy, rewarding adaptation. The influence of gravity extends beyond the human form. Long before the first vertebrate emerged from the sea, ancient plants learned to grow roots into the Earth's pull and stretch stems toward the light above. Even at the microscopic level, single cells could sense direction, distinguishing up from down by how their internal fluids settled. This simple physical bias guided evolution, weaving the expectation of weight into the foundation of life. Consider what would happen if that expectation was suddenly removed. Every organ, every motion, every reflex depends on a force that has never once been absent since the dawn of biology. Bones expect pressure, hearts expect resistance, and eyes expect a horizon to orient against. Evolution has no memory of freedom from gravity, no alternative design for motion or rest without weight. The human body is a machine engineered to live under pressure, and without that pressure, the machinery begins to lose its purpose. Even the concept of balance is born from gravity. When a child learns to walk, each stumble is a conversation with the Earth's pull. The nervous system refines itself by predicting how far the center of mass can lean before gravity takes control. Over time, this invisible dialogue becomes instinct. Yet if gravity were gone, the conversation would end, and instinct itself would lose its meaning. From the curvature of the spine to the tiny sacs of the lungs that open and close with each breath, every structure carries the signature of the planet's weight. The heart beats upward against gravity, sending blood to the brain with every contraction. The veins in the legs have valves that prevent blood from pooling under the constant downward pull. Even the skin thickens in places where it bears more pressure. Every species on Earth is, in a sense, an expression of gravity's design. Birds developed hollow bones, not only for flight, but to balance the demands of lift against the weight of their bodies. Fish use the buoyant resistance of water to mimic gravity's pressure. Humans evolved arches in their feet to absorb the constant impact of standing and walking against the pull of the Earth. The very geometry of anatomy, the curves, the supports, the layers, mirrors the logic of an engineer who has been shaping life for billions of years. In laboratories on Earth, scientists can simulate weightlessness for only seconds at a time. During these brief moments, they observe how quickly the body begins to lose its reference points. Muscles relax, eyes misjudge distance, and fluids in the body begin to shift upward. Even in such short tests, it becomes clear that gravity is more than a physical condition. It is a biological expectation, a constant in the algorithm of life. Yet humanity has always been restless under this sculptor's hand. The same force that grounds us also binds us. For centuries, we have looked toward the stars and wondered what it would mean to be free from the pull of the Earth. When the first astronauts left the planet, they carried not only machinery and fuel, but also a body that had never known any other environment. The moment their spacecraft crossed into orbit, they entered a realm that life was never built to inhabit. In that instant, gravity's absence revealed its importance. Astronauts describe the first sensation of weightlessness as both liberating and unsettling. Objects drift, bodies float, and for a moment, it seems as if the laws of nature have been suspended. But soon, the body begins to protest. Blood moves where it should not. Muscles no longer anchor the bones. The equilibrium of the inner ear spins into confusion. The sculptor may be gone, but its design remains, and it begins to unravel without its maker. Gravity is more than a number on a physics chart. It is memory, structure, and the pulse that keeps life organized. Every habit of the body, from the way we sleep to the way we dream of flight, carries its influence. Even language reflects its dominion. We speak of feeling grounded, of falling in love, of rising above. Our metaphors betray our inheritance from this constant companion. If the story of life on Earth were a sculpture, gravity would be the artist's hand, shaping every contour, every fragile detail, with patience measured in eons. It is the weight that defines lightness, the anchor that gives meaning to motion. And yet, for all its familiarity, we scarcely understand what happens when it lets go. The moment a human drifts beyond the reach of the Earth's pull, a new chapter of biology begins, one where the sculptor's absence tests the resilience of its creation. In orbit, the rules of evolution meet their first true exception. The human body, once molded by weight, must now learn to exist without it. Muscles, bones, and blood all begin to rewrite their functions in a silent dialogue with the void. The story of this adaptation is both fragile and profound, for it reveals not only how gravity shaped us, but also how deeply we belong to it. And so, as the engines of a spacecraft ignite and the horizon curves beneath its hull, the question rises quietly above the roar. What happens to the human form when the sculptor steps away? The answer waits beyond the sky, where gravity fades and the true test of life begins. When a spacecraft leaves the grasp of the Earth, it carries more than metal and circuitry. It carries the weight of biology itself. The transition from the ground to orbit is not a simple matter of distance, but a rewriting of physical law. Inside the capsule, the pull of 9.8 meters per second squared fades until it is replaced by a strange equilibrium. Astronauts describe this moment not as freedom, but as falling forever. In truth, that is precisely what they are doing. The spacecraft and everyone inside are in continuous free fall around the Earth, moving forward so quickly that the planet curves away beneath them. The illusion of weightlessness is born not from the absence of gravity, but from its perfect balance with motion. For the first time in human history, we created an environment where gravity's script is erased. Yet the human body, sculpted over millions of years to obey that script, does not forget so easily. Within moments of entering orbit, every cell begins to sense the missing pull. Blood that once pooled in the legs begins to migrate upward. Astronauts awaken with swollen faces and pressure behind their eyes. The body, designed to work uphill against gravity, suddenly finds itself with no direction to push. The inner ear, with its delicate semicircular canals filled with fluid, is among the first to lose its bearings. These canals evolve to measure acceleration and orientation relative to gravity. In microgravity, they send signals that no longer match what the eyes see. The result is disorientation, nausea, and a feeling that up and down have ceased to exist. For some, this confusion lasts a few hours. For others, it endures for days. It is a strange irony that one of the first challenges in space is not learning to float, but learning how to stand still in a world where standing no longer means anything. The shift of fluids toward the head has consequences beyond discomfort. Pressure on the eyes can flatten the globe and alter vision, a condition known as space-associated neuroocular syndrome. Even the sense of taste changes, as congestion dulls flavor and smell. To counter this, astronauts often crave spicy food, seeking strong signals in a dulled sensory world. Meanwhile, the legs, now deprived of their usual blood volume, begin to look thin and pale. The iconic puffy face and chicken legs effect of space travel is not a sign of adaptation, but of imbalance, a body still searching for gravity's lost map. The heart, too, feels the difference. On Earth, it works tirelessly to send blood upward against gravity's pull. In orbit, the effort is unnecessary. The heart relaxes, its walls begin to thin, and its overall mass decreases. The reduction in workload feels like relief, but it is the kind that weakens over time. When astronauts return to Earth, the heart must suddenly work against gravity again, and many experience dizziness or even fainting upon standing. What feels effortless in space becomes a burden once more under the sculptor's hand. The skeletal system, however, tells the most dramatic story. On Earth, bones continuously rebuild themselves in response to the stresses of weight and motion. Cells known as osteoblasts lay down new material, while osteoclasts break down old tissue. This constant exchange keeps bones dense and strong. In space, where weight vanishes, the balance tips sharply toward destruction. Osteoclasts continue their work, but osteoblasts slow dramatically. Bones lose minerals into the bloodstream, calcium levels rise, and within a month, the loss of bone mass can reach 1 to 2%, 10 times faster than in an elderly person with osteoporosis on Earth. The femur, spine, and pelvis suffer the most, places where gravity's demand is usually greatest. The first astronauts to experience long missions returned home with bones so weakened that fractures were a real risk. It became clear that exercise alone could not perfectly replace the mechanical stimulus of weight. Yet the human species is nothing if not inventive. Engineers designed the Advanced Resistive Exercise Device, a machine that mimics the strain of lifting weights by using vacuum cylinders and cables. Astronauts spend hours each day on this device, strapping themselves in to simulate the downward force their bodies crave. Still, the imitation is imperfect. Gravity is not just a direction, it is a continuous conversation between mass and motion that no machine has yet fully recreated. Even with these precautions, the transformation continues. Muscles that once held the body upright begin to melt away. The postural muscles, the calves, thighs, and back, weaken first. Fibers shift from slow twitch, built for endurance, to fast twitch, built for bursts of effort. The result is a body that feels strong in short motions, but fragile over time. Some astronauts lose as much as 20% of their muscle mass in less than 2 weeks without rigorous exercise. Their bodies become lighter, not only in mass, but in meaning, shedding the layers of adaptation that once defined what it meant to stand on Earth. Inside this floating laboratory, every heartbeat and every step on the treadmill becomes a question. What is the minimum requirement for human life to remain human? The mind adjusts quickly, perhaps too quickly. Within days, floating feels normal. Astronauts speak of forgetting what weight felt like. Tools drift effortlessly to hand, and motion becomes ballet-like, graceful, and dreamlike. Yet beneath that grace, the body is quietly surrendering its ancient memory of pressure and strain. The absence of gravity reveals its paradoxical nature. It was once seen as an obstacle, a force to overcome in the dream of flight. Now, in its absence, we understand it as the very foundation of vitality. Without gravity, the skeleton softens, the muscles fade, the heart shrinks, and even thought begins to drift. The sculptor's absence does not bring freedom, it brings forgetting. As the weeks pass, astronauts notice subtler changes. The spine elongates as the compression of discs vanishes. Some grow several centimeters taller, though the change is temporary. Joints loosen, posture shifts, and the act of movement becomes something new. Not a resistance, but a suggestion. In the mirror of the spacecraft's window, they see not the heroic figure of a spacefarer, but a body midway through transformation, a being halfway between Earth and the void. Outside the window, Earth turns in silence. The continents move below, like a living map of color and motion. From orbit, there is no sensation of speed, no rush of wind, only the eternal drift. Yet within that stillness, the body continues to change, molecule by molecule, adapting to a place where up and down have no meaning. The sculptor's hands are gone, and the clay begins to remember its formlessness. Still, adaptation is never one-sided. For all that gravity has taken from them, astronauts find new ways to move, new rhythms to live by. They learn to use fingertips for propulsion, to glide with the gentlest push, to turn and spin in silence. Muscles recalibrate, reflexes adjust, and the nervous system begins to accept this new equilibrium as normal. In time, the body stops fighting and begins to learn. Evolution may be slow, but the brain is quick. It writes new equations, teaching balance without weight, motion without fall. This is the beginning of a deeper transformation, one that reaches beyond bones and muscles into the language of the cells themselves. For gravity's absence does not merely alter how we move, it alters how we are built. Within the quiet hum of the spacecraft, the sculptor's influence fades from memory, and a new blueprint of humanity begins to take shape, fragile, floating, and free from the weight of the world. There is a quiet truth hidden in the heart of space travel. The moment the pull of the Earth is gone, the human body does not simply float, it begins to forget. Every cell that once obeyed, the language of weight must now learn a new dialect, one written in absence. This forgetting is not sudden. It is slow and graceful, almost poetic. Yet beneath that beauty lies a biological unraveling that challenges the very definition of life as we know it. Imagine the skeleton, that silent framework of endurance, suspended in a world without pressure. Each bone is a monument to struggle, built through generations of standing, falling, and rising again. On Earth, the skeleton is alive in a mechanical sense, constantly sensing and responding to load. But in space, its dialogue with gravity ends. The bones no longer hear the call to grow dense and strong. Instead, they listen to stillness. The result is a creeping fragility, invisible yet profound, as calcium leaches into the blood and the architecture of the body begins to hollow from within. This slow erosion mirrors the greater paradox of space itself. Humanity dreamed of escaping gravity to find freedom among the stars, yet what we found instead was dependence. We discovered that gravity is not a prison, but a partner. Without it, we lose not only strength but orientation, rhythm, and even the subtle cues that tell the brain where the body ends and the world begins. The vestibular system, that delicate balance organ deep within the skull, depends entirely on gravity's whisper to understand motion. Deprived of that signal, the mind floats as aimlessly as the body, adrift in a sea of unanchored perception. Astronauts often describe dreams in space as strange and luminous. They dream of falling, of flight, of standing again on solid ground. The brain, it seems, continues to seek gravity even in sleep. The absence of downward pull rewires the body's circadian rhythm. Without sunrise or sunset, the internal clock loses its calibration. Sleep comes in short fragments, punctuated by bursts of wakefulness as the spacecraft glides through alternating day and night every 90 minutes. The body, unmoored from the planet's rotation, begins to drift through time itself. Within this new rhythm, adaptation continues. The cardiovascular system recalibrates, reducing blood volume to match the headward shift of fluids. The kidneys respond as if the body was swollen, excreting water and salts. The result is dehydration, a dry mouth, and a lowered plasma volume that further weakens the return to Earth. Even the heart's shape begins to change. Without gravity's demand to pump upward, it takes on a more spherical form, losing the muscular tone that defined its terrestrial efficiency. To counter this, astronauts spend hours each day attached to machines that mimic gravity's effects. They run on treadmills with harnesses pulling them downward. They cycle against resistance, push and pull levers that simulate weight, and compress their bones and joints through artificial strain. The routine is relentless, a ritual of remembrance for a body that cannot afford to forget. And yet, even with these measures, the change is inevitable. The sculptor's absence cannot be fully replaced by imitation. There is, however, a deeper question that echoes through these experiments. If gravity has shaped every feature of life on Earth, what would life become without it? The human body, deprived of pressure, begins to seek new balance points. Over generations, if humanity were to live in microgravity, evolution itself would respond. The skeleton might grow lighter and more flexible, the muscles thinner, the circulatory system more centralized. Perhaps humans would become taller, their limbs more delicate, their eyes larger to navigate dimly lit habitats. Such changes would not merely be adaptation, they would be a new branch of our species, children of the void rather than the soil. And yet, even as the body adjusts, the mind clings to memory. The sense of falling, of having a place called down, remains deeply rooted in consciousness. When astronauts close their eyes, they still imagine themselves standing upright, still feel the ghost of weight pressing against their feet. This phantom gravity is not an illusion, but a remembrance, proof that the body and the planet are inseparable in ways that go beyond physics. When they finally return to Earth, the reunion is both painful and profound. The first step back under the weight of 9.8 meters per second squared feels unnatural. Legs tremble, hearts labor, and bones groan under the sudden restoration of their ancient companion. Astronauts describe it as being hugged by the planet, as if the Earth itself were reclaiming them molecule by molecule. Yet behind that poetic reunion lies struggle. The muscles ache from disuse, the bones cry out in protest, and the balance system falters as it relearns which way is down. It is a second infancy, a rebirth under gravity's gaze. The recovery process can take months. Exercise, nutrition, and medical monitoring become part of daily life. The skeleton slowly rebuilds density, the heart regains its strength, and the blood once again learns to climb. In these months, scientists see a mirror of evolution itself compressed into human time. Adaptation to gravity, which once took millions of years, now plays out within a single lifetime, leaving behind data, insight, and awe. Through this cycle of departure and return, one truth becomes clear. Gravity is not a burden to escape, but a teacher to understand. It is the sculptor of bodies and the rhythm of existence. Without it, we unravel. With it, we endure. The dream of exploring the stars is not a rebellion against this force, but a conversation with it, a dialogue written in bone, blood, and breath. As the spacecraft re-enters the atmosphere, the heat shield glowing with friction, the crew inside brace themselves for the final return to weight. Flames streak past the window, and the blue curve of the planet brightens below. The heartbeats quicken, muscles tense, and the body prepares to meet its oldest companion once again. Then, with a shudder and a roar, gravity takes hold. It pulls them home, not as conqueror and captive, but as creator and creation reunited. In that moment, amid the deceleration and the rising sound of the wind, the truth of the sculptor becomes undeniable. Gravity is not simply what keeps us bound to the Earth. It is what gives us form, memory, and purpose. Every step we take, every breath we draw, is an echo of that ancient partnership. We are not just creatures who live under gravity. We are children of it, shaped by its hand and forever defined by its embrace. The story of leaving gravity begins with thunder. The rocket's engines awaken the sky, shaking the launch pad and every molecule of air around it. Inside, the astronauts sit strapped to their seats, their bodies compressed beneath a growing weight that feels both familiar and defiant. Gravity is clinging to them, holding them as tightly as it can. For a few fleeting moments, every heartbeat, every breath, every muscle trembles under the pull of the planet. The roar outside is not merely sound, but resistance, the voice of the Earth refusing to release its children. Acceleration builds. The spacecraft rises, cutting through the thick layers of atmosphere, where air resists and friction bites. Within minutes, the world below begins to curve. Oceans and continents blend into a single blue mosaic. The pull that has defined human life for all of history begins to fade. The numbers that once meant security, 9.8 meters per second squared, diminish until they approach zero. And in that moment, the sculptor of life lets go. Silence replaces thunder. The engines shut down, and everything inside the spacecraft transforms. The straps that once pressed against the astronauts' chests no longer hold weight. Objects that moments ago obeyed gravity now drift, indifferent to direction. A pen escapes a hand, floating like a thought freed from structure. An astronaut lifts a finger and feels no resistance, no weight, only the strange equilibrium of motion without force. The term for this condition is microgravity, not zero gravity, because gravity is never truly gone. Even at the altitude of the International Space Station, the pull of the Earth is still about 90% as strong as it is on the surface. The illusion of weightlessness arises because the spacecraft and everyone inside are falling together at the same rate. The astronauts are not floating. They are in a perpetual state of free fall, circling the planet once every 90 minutes. It is gravity that keeps them in orbit, pulling them toward the Earth, even as their motion carries them forward fast enough to miss it. This balance between fall and flight is delicate, and it defines life in orbit. For those who experience it, the first moments are filled with confusion and wonder. The sense of up and down disappears. A glance at the window shows the blue curve of Earth below, but within the cabin, orientation becomes meaningless. Some astronauts instinctively try to stand, others to sit, but neither action has purpose. The body is a compass without a north, spinning gently in a world where direction has no meaning. Then comes the rush of blood. On Earth, gravity draws fluids downward, pulling them in the legs. In microgravity, that pull vanishes. Blood and other bodily fluids drift toward the chest and head, creating the characteristic puffy face and bird legs of spaceflight. Astronauts feel congested, as if lying upside down. Their eyes swell, their noses block, and some experience headaches as pressure builds within the skull. The body has been programmed for a world with a downward direction, and now, stripped of that axis, it reacts with confusion. The heart senses this change almost immediately. No longer required to push blood uphill, it eases its effort. Stroke volume, the amount of blood pumped with each beat, decreases. The muscle itself begins to shrink in mass. What feels effortless is, in truth, a slow weakening. For a body born under gravity, effort is health. Without that demand, systems fall into dormancy. Astronauts quickly learn to adapt. They tether sleeping bags to the walls, securing themselves so they do not drift aimlessly through the cabin. Eating becomes a careful ritual. Food comes in packets and drinks through straws with valves, for a single drop of water floating loose could drift into electronics or lungs. Every motion is planned. Every object must be secured. In the absence of gravity, chaos is only a breath away. Yet amid the adjustment, there is beauty. The freedom from weight carries a sense of dreamlike wonder. Astronauts move through the station like dancers, gliding with a single touch, turning somersaults without effort, laughing at the ease of motion. The childlike joy of floating merges with the scientists' fascination, as they watch how every law of motion still applies but in new and unexpected ways. A push against one wall sends them sailing to another, equal and opposite reaction guiding their glide through the air. Newton's third law is alive and visible in every movement. Still, the novelty fades into realization. The body, though exhilarated, begins to change. Muscles that once fought to hold posture now have no job. The legs, calves, and lower back, those constant defenders against gravity, relax into idleness. Within days, they begin to atrophy. The body's sense of necessity shifts. It learns that work is no longer needed to remain upright. And in that forgetting lies the first step of transformation. The bones too begin their silent surrender. In the absence of weight, the signals that tell bone cells to rebuild grow faint. Osteoclasts, which remove old bone tissue, continue their work, while osteoblasts, which build new bone, slow to a near halt. Calcium leaches into the bloodstream and density declines. The same process that on Earth takes years in the elderly unfolds in weeks among the stars. The skeleton, once a fortress of endurance, becomes brittle glass. To counter this decay, astronauts spend hours each day attached to machines designed to mimic gravity's demand. They run on treadmills using harnesses that pull them down. They lift against vacuum resistance. They pedal on stationary bicycles fixed to the station's structure. The effort is immense, not only physically but psychologically. Every workout is a negotiation with memory, a reminder of what gravity once required and what its absence slowly erases. Despite all efforts, the shift continues. The human body was never meant to live without gravity's pull. Evolution has had billions of years to perfect life under pressure, and only decades to confront life without it. The adaptation is ongoing, incomplete, and deeply humbling. For all our technology and courage, we remain creatures of a planet, dependent on a force we cannot see yet cannot live without. As the spacecraft orbits Earth, the astronauts peer down at the world that made them. Oceans shimmer in sunlight, clouds swirl like living veins, and cities sparkle like constellations of human intention. From this height, gravity's influence is invisible yet absolute. It holds the planet together, keeps the air wrapped around it, the oceans pressed to its surface, and the moon bound in its dance. The astronauts, weightless and free, are still its children, not beyond gravity, but within its reach, tracing the edge of its endless circle. This is the paradox of spaceflight. To escape gravity is to depend on it more deeply than ever. The very orbit that grants weightlessness exists because of gravity's perfect balance with motion. Without that invisible tether, the spacecraft would drift into the dark, away from the sun, away from the Earth, away from everything that once meant home. The astronauts may float, but they are still falling, forever falling, around the world that made them. And as they drift in that eternal descent, they begin to sense a deeper truth. The absence of gravity is not an escape, but an experiment, one that reveals just how profoundly the force has shaped not only their bodies, but their minds. For in the silence of space, the body forgets weight, but the soul does not. The longing for ground, for downwardness, for belonging, endures. In that longing, humanity rediscovers not its power to escape, but its unbreakable connection to the planet that gave it form. The sculptor has let go, but its influence remains etched into every heartbeat, every motion, every drifting thought. To leave gravity is to understand it for the first time. Not as a prison, but as the quiet architecture of existence. And as the astronauts circle above the world, watching the sun rise 16 times each day, they begin to see that leaving gravity is not departure, but revelation. It is a reminder that the farther we travel into the void, the more clearly we understand the pull that made us who we are. The body's relationship with gravity is so ancient that when it vanishes, even the smallest systems begin to question their purpose. Within hours of entering orbit, the internal organs experience a quiet confusion. The stomach, liver, and intestines, once accustomed to settling in predictable directions, begin to float within their cavities. The usual cues that guide digestion, the downward pull that helps food move, are gone. Meals must be eaten slowly, in small portions, because the simple act of swallowing becomes a negotiation between muscle memory and physics. Without gravity, nothing falls. Everything must be pushed or guided. The bloodstream mirrors this disorientation. On Earth, the heart's contractions send blood upward against gravity to nourish the brain. Veins in the legs rely on one-way valves to prevent backflow. In microgravity, these valves fall silent, their role erased. Blood pools in the upper body, causing a swelling sensation in the head. The face grows rounder, eyes bulge slightly, and pressure increases behind the retina. Some astronauts describe it as wearing an invisible helmet filled with water. Over time, this pressure can flatten the back of the eye and distort vision. A subtle reminder that gravity's absence is not peace, it is imbalance. The heart itself, no longer burdened by the need to fight gravity, begins to relax more than it should. Its walls thin, its volume shrinks, and its rhythm slows. In the short term, this feels effortless. The pulse becomes steady, the breath light, the body calm. But this calm is deceptive. The heart is a muscle that depends on resistance to remain strong. In space, where resistance disappears, the muscle forgets its strength. When astronauts return to Earth, many experience orthostatic intolerance, the inability to stand without fainting. Their bodies have forgotten how to send blood uphill. What was effortless in orbit becomes exhaustion on the ground. This circulatory transformation affects more than the body's mechanics. It reshapes sensation. The skin becomes hypersensitive, nerves misfire, and joints send conflicting messages about position and movement. The brain, which depends on input from muscles, eyes, and the inner ear to construct balance, receives a flood of contradictions. The vestibular system inside the skull, filled with fluid that normally responds to acceleration, now drifts in confusion. Without a gravitational vector, the brain cannot tell up from down. Vision no longer matches motion, and nausea follows. This is space motion sickness, the most common illness in orbit. Even the most trained astronauts must endure days of dizziness before their brains rewrite their expectations. Yet adaptation comes, as it always does. The human nervous system, though born of gravity, is capable of extraordinary flexibility. After several days, the brain begins to ignore the conflicting signals and recalibrates. A new sense of orientation emerges, one that does not depend on up or down, but on context and familiarity. The brain decides what is floor or ceiling based on experience alone. Astronauts begin to move with confidence, to flip and turn without confusion. What once caused sickness now becomes second nature. In this, we see evolution in fast motion, the brain rewriting millions of years of instinct in a matter of days. But while the mind adapts, the body continues its slow unraveling. The loss of mechanical load changes how genes express themselves. Proteins that control muscle growth decline in production, while those linked to breakdown increase. The immune system, deprived of its usual stress environment, weakens. Wound healing slows, inflammation behaves unpredictably, and even the microbiome within the intestines begins to change composition. Bacteria that once lived peacefully can grow more aggressive in microgravity, and antibiotics may lose some of their effectiveness. The body, once a fortress under gravity's sculpting pressure, becomes porous in its absence. To manage these shifts, astronauts follow strict daily schedules. Every moment of their time is measured, for structure itself becomes a substitute for the lost order that gravity once provided. Exercise cycles, mealtimes, experiments, communication with Earth, all follow rhythm. This imposed cadence helps anchor the circadian clock, which otherwise would drift in the artificial lighting of the station, where sunrise and sunset come 16 times each Earth day. Without that structure, sleep collapses into fragmented rest. Some astronauts report vivid, surreal dreams of floating oceans, of endless descent, of falling upward. The subconscious, still tethered to gravity, dreams of it even when awake. As weeks turn to months, the human body continues to evolve within the confines of the spacecraft. The spine elongates as the compression of vertebrae releases, giving astronauts an increase in height by as much as 5 centimeters. This change sounds benign, even pleasant, yet it comes with pain. The stretching of ligaments and discs causes discomfort, sometimes sharp enough to limit movement. The very freedom that microgravity promises extracts a price from the structures that once bore weight. Meanwhile, the face of adaptation deepens. The body, floating in this artificial environment, begins to behave as though it belongs here. The cardiovascular system settles into a new equilibrium. The muscles adapt to partial use, and even the bones slow their loss as cellular processes adjust to new patterns. The human form, it seems, can find balance in almost any condition. Yet this equilibrium is temporary, a fragile pact between biology and physics. For when the time comes to return home, that equilibrium will shatter under the weight of the world. The paradox of leaving gravity is that it reveals how profoundly we depend on it for identity. On Earth, gravity defines orientation, effort, and even emotion. To stand upright is to resist, to fall is to yield. In space, these metaphors lose their grounding. There is no falling, no rising, no sense of direction in which to strive. This absence seeps into consciousness. Astronauts describe moments of quiet introspection where they lose track not only of up and down, but of self and other. The boundaries blur. Without gravity's pull to separate sky from soil, the mind begins to sense its own place in a wider continuum. It is both humbling and unsettling, a confrontation with the possibility that gravity is not merely a force of physics, but an anchor of meaning. Outside the station's window, the Earth glows silently. From this height, gravity's power is invisible but total. It holds oceans in their basins, clouds in their spiral paths, mountains in their quiet defiance. Every motion below, every wave, every breeze, every heartbeat is a reply to its command. The astronauts, though free from its immediate grip, still orbit in obedience. The truth becomes undeniable. They have not escaped gravity. They have learned to live within its absence while still belonging to its reach. And as they float through the corridors of the station, turning gently with each motion, they begin to see gravity not as something that holds them down, but as something that holds everything together. To leave it behind is not to abandon it, but to understand it, to witness how deeply woven it is into the fabric of existence, from the arc of a planet's path to the quiet rhythm of a human pulse. The farther one drifts from the surface of the Earth, the more clearly one feels what has been lost. The body may adapt to weightlessness, but the soul continues to search for the steady pull of home. Time itself seems to loosen its structure in orbit. Days and nights come too quickly, 16 cycles every 24 hours, each one marked by the sun slicing across the horizon and disappearing again into darkness. The rhythm of the planet, once embedded in every cell of the body, becomes noise. Astronauts learn to sleep not by the light of dawn or dusk, but by command, closing their eyes on schedules drawn by mission control. The body resists, then obeys, creating an artificial day inside a perpetual twilight. In this strange environment, the mind begins to change. The absence of gravity does not merely affect the muscles and bones, it transforms perception itself. Without a constant downward reference, the brain loses its intuitive sense of size and distance. Objects appear to float closer or farther, depending on how they drift. Tools that once felt heavy now move with deceptive ease, making it difficult to judge how much force to apply. The effort of motion becomes more about precision than power. To move in space is to think before every gesture, to choreograph even the smallest reach. It is not walking or running, but a kind of learned dance through invisible currents. This transformation extends inward. The vestibular system, that delicate pair of organs in the inner ear that once defined balance, grows silent. In its place, the brain learns a new equilibrium based entirely on vision. Orientation becomes a matter of perspective. Astronauts can choose which direction is up simply by deciding it. Some orient themselves so that Earth is always beneath them, others so that the sun or a star becomes their compass. In this, the human mind reveals its greatest strength, the ability to redefine normal. But this new normal carries a price. When the vestibular system no longer senses gravity, the neural circuits that depend on it for awareness of motion grow idle. Upon return to Earth, the reawakening of these circuits feels like vertigo, a rush of remembered weight that the body must once again learn to bear. Long-duration missions deepen this cognitive shift. Over time, astronauts describe a phenomenon known as space fog, a mild but persistent difficulty in focusing attention and judging time. The brain, deprived of ordinary sensory cues and regular sleep, begins to drift just as the body does. Concentration blurs at the edges. Tasks that once felt automatic demand conscious thought. Even emotion softens into neutrality. Anger, excitement, fear, all seem distant, diffused by the constant sameness of the environment. The mind becomes like the orbit itself, a steady repetition around the familiar without ever touching it. And yet, amid this detachment, there arises a new kind of awareness. Looking down through the small circular windows of the station, astronauts witness Earth not as a collection of nations and borders, but as a single luminous organism. The thin blue line of the atmosphere glows like the breath of life itself, fragile and irreplaceable. Storms spin in silence, lightning flickers like neurons across the surface of a sleeping brain, and deserts gleam like ancient scars. From this distance, gravity is no longer felt through the feet but seen in motion. The tides, the clouds, the swirling dance of continents held in balance by the same force that once held their own hearts steady. In moments of stillness, this view becomes almost spiritual. Some astronauts describe it as an awakening, a sudden, overwhelming understanding that everything alive shares the same dependence on gravity, light, and air. The separation between self and planet fades. What was once simply a home becomes a living companion, a body orbiting the sun as surely as their spacecraft orbits it. The realization is both beautiful and heavy with consequence, for it means that every step into space, every act of exploration, is also an act of leaving part of oneself behind. Even communication with Earth reinforces this distance. The voices from mission control, calm and precise, reach them through seconds of delay. Each word has traveled through space, carried on invisible waves, weakened by distance. The sound of human speech becomes something precious, fragile, and finite. Astronauts begin to measure time not by hours or days, but by conversations, by the rhythm of connection and silence. In those intervals of silence, the weight of isolation becomes real. The station hums softly with machinery, fans, and life support systems, but beyond its walls lies infinite stillness. It is a silence so complete that it presses inward, demanding acknowledgement. The human mind evolved under noise, wind, water, heartbeat, the rustle of movement. In space, where sound cannot travel beyond airlock chambers, that sensory expectation collapses. Thought becomes louder, introspection sharper. Astronauts often describe sudden floods of memory, long-forgotten moments from childhood, faces of people they have not seen in years. It is as though the absence of gravity loosens not only the body's fluids but the mind's boundaries as well. Memory drifts freely, untethered by the anchors of daily life. Yet for all the strangeness, there is harmony in this disconnection. Weightlessness offers a serenity that no earthly experience can replicate. To float without effort, to see the planet suspended in blackness, to witness sunrise and sunset without the passing of time. these experiences alter one's sense of being. Astronauts return home, changed not only in physiology but in philosophy. They speak of gravity not as a simple pull, but as belonging. They describe the moment of re-entry, when the body begins to feel heavy again, as a return not merely to the planet, but to meaning itself. The experiments aboard the station continue. Studies on bone loss, muscle degradation, fluid shifts, immune response. Each observation deepens understanding. Each sample adds to the map of how gravity defines life. Scientists track molecular changes, gene expressions, even shifts in the rhythm of heartbeat and breath. They learn that the absence of gravity is not neutral. It is a profound biological challenge, one that tests the very foundations of life's design. Every adaptation seen in orbit is a reminder of how precisely evolution tuned the human body to one environment, a narrow range of pressure, light, and pull. One day, when humanity sets its sights on longer journeys, to the moon, to Mars, beyond, this knowledge will be our lifeline. Artificial gravity, rotational habitats, and pharmacological interventions will all trace their origins to the lessons learned by those who left gravity behind. But even as technology advances, one truth will endure. Gravity is not just a condition to be recreated, it is a companion to be respected. To live without it is to live in suspension, physically and spiritually, between the familiar and the unknown. As the spacecraft completes yet another orbit, sunlight floods the cabin, igniting reflections on the walls, on instruments, on faces. Outside, the Earth glows beneath them, its oceans rippling in slow motion, its clouds stretching into spirals that mark the breath of weather. The astronauts, drifting quietly, realize that they are not apart from this scene, but part of its equilibrium. They are both within gravity and beyond it, sustained by the very force they sought to escape. To leave gravity is not to abandon it, it is to carry its memory into the void, to feel its absence as presence, and to understand that everything that lives, from the smallest cell to the brightest star, is forever in conversation with the pull that binds the universe together. In that realization lies the quiet triumph of exploration. Not escape, but return through understanding. In the absence of gravity, the body begins to forget what it means to bear weight. Every structure that once resisted the pull of the Earth starts to loosen its purpose. The skeleton, that silent framework that has carried humanity through millennia, begins its slow unraveling. Each bone is more than mineral. It is a living archive of pressure, impact, and resistance. On Earth, this balance between stress and recovery keeps the bones dense, strong, and alive. But once the sculptor's hand of gravity is lifted, that balance collapses. Bones are built through conversation between two types of cells. Osteoblasts, the builders, lay down new tissue in response to load. Osteoclasts, the dismantlers, clear out old or damaged material. In a healthy body, their rhythm is harmonious, a steady cycle of destruction and renewal. Yet in space, where mechanical strain is gone, the builders fall silent, while the dismantlers continue their work. The result is a slow erosion of the skeleton from within. The calcium that once fortified bone leaks into the bloodstream, raising its concentration to dangerous levels and forcing the kidneys to work harder to expel it. This loss is not merely theoretical. Measurements from astronauts aboard the International Space Station reveal that the femur, pelvis, and spine can lose 1 to 2% of their mineral density per month in microgravity. That is 10 times the rate of an elderly person suffering from osteoporosis on Earth. The change is so rapid that after a year in orbit, an astronaut's bones can be as fragile as those of someone decades older. The simple act of standing upon return becomes a challenge, and the risk of fracture multiplies. To the astronauts who experience it, the process is imperceptible. There is no pain, no warning, only the knowledge that beneath the surface, the structure that has always held them upright is quietly dissolving. On Earth, gravity's constant tug compresses the skeleton, signaling it to remain strong. Every step, every jump, every impact is a small reminder that resistance is required. In orbit, that reminder disappears, and the body begins to interpret stillness as safety. The bones surrender to the illusion of rest, unaware that rest itself has become the danger. Scientists describe this process as disuse atrophy, a condition where the absence of load leads to biological neglect. It occurs in bedridden patients, in those who suffer prolonged immobilization, and in every human who spends time beyond the atmosphere. The same biology that protects bones from waste on Earth betrays them in space. It is not malfunction, but misinterpretation. The body's attempt to adapt to a world it was never meant to inhabit. To counter this, engineers have created tools that simulate the burden of gravity. The Advanced Resistive Exercise Device, or ARED, is a machine that uses vacuum cylinders and pulleys to create resistance equivalent to lifting weights on Earth. Astronauts spend 2.5 hours every day attached to it, straining their muscles and bones to preserve what the environment seeks to erase. It is a daily ritual of defiance against decay, yet even this is not perfect. Gravity acts continuously, 24 hours a day, while these exercises offer only fragments of simulation. The body senses the difference, and adaptation continues its quiet erosion. The effects of bone loss reach far beyond the skeleton. As calcium seeps into the blood, it alters the chemistry of the body. The kidneys, tasked with filtering the excess, become overworked. The risk of kidney stones increases. Muscles attached to weakening bones lose their anchor points, compounding their own degradation. Even the immune system, sensitive to the minerals circulating through plasma, responds with confusion. In space, the breakdown of one system ripples through them all. Despite these challenges, astronauts adapt with resilience. They approach exercise not as a chore but as survival. The metallic clang of the ARED, the rhythmic motion of the treadmill, the silent resistance of elastic bands, all become echoes of gravity itself. Each repetition is an invocation of Earth, a memory of weight. The body remembers through movement, even when the world around it is still. What is most striking is how quickly the bones begin to recover once the astronauts return home. Within weeks of re-entering gravity, osteoblasts awaken. The pressure of walking, the resistance of standing, the simple act of feeling one's own weight becomes signals of renewal. The skeleton responds as though remembering a forgotten language, yet full recovery can take years, and some density is never regained. Gravity, once lost, never returns completely. The lessons from these journeys reach beyond the realm of spaceflight. On Earth, scientists study astronauts to better understand diseases of bone loss and aging. The laboratory of the cosmos becomes a mirror for human frailty. Every mission adds to a growing body of knowledge about how life depends on pressure, on stress, on the dialogue between force and form. Gravity is not merely a condition of existence, it is a constant teacher, shaping the rules by which life maintains itself. Looking deeper, one realizes that the skeleton is not an isolated structure, but an organ of memory. It records not only motion, but experience. The grooves of joint surfaces, the density of trabecular bone, even the curvature of the spine, all bear the marks of a life lived under gravity's guidance. To remove that force is to erase part of the story written in bone. In orbit, that story pauses, suspended between creation and decay, waiting for the return of the sculptor's touch. Outside the spacecraft, Earth continues to turn, bound by the same force that the astronauts now miss. From this distance, the planet itself appears fragile, delicate, luminous against the void. Its mountains, carved by gravity's patient hand, rise like frozen waves. Its rivers trace paths dictated by the downward pull, carrying minerals from summit to sea. Even the atmosphere, thin and glowing, clings to the planet because gravity wills it so. To look upon it from space is to witness the sculptor's masterpiece. a world shaped entirely by the force the astronauts now lack. And yet, within this absence, there lies discovery. The weakening of bones in space is not merely loss, it is revelation. It shows how dynamic life truly is, how quickly it adapts when its oldest partner is taken away. It teaches that form is never static, that the body is not a fixed monument, but a conversation between physics and biology. The skeleton, stripped of gravity's demand, becomes a living experiment, one that speaks to the essence of what it means to be human. When the mission ends and the spacecraft falls through the atmosphere, fire licking its surface, gravity reclaims its own. The bones, still fragile, feel the first hint of weight pressing back into them. The return is both punishment and grace. Every step upon landing is agony and rebirth, a reunion between the body and the planet that made it. The skeleton groans in recognition, welcoming the sculptor's touch once more. For in the end, the story of bone loss in space is not one of defeat, but of perspective. It reminds us that gravity, though invisible, is the constant artist of our existence. It shapes us in silence, carves our strength from resistance, and keeps us bound to the rhythm of the world. Without it, we fade. Not because we are weak, but because we were never meant to forget the hand that holds us. When an astronaut drifts through the corridors of a spacecraft, it is easy to believe that the body has escaped the burden of weight. Yet every movement hides a deeper consequence. The skeleton, relieved of pressure, begins to drift inward, turning fragile from neglect. The first signs are invisible, microscopic changes in the balance between the cells that build and those that break. Without the tiny jolts of impact from walking or standing, the osteocytes, the bone's sensory cells, fall silent. Their silence tells the body that strength is no longer needed. On Earth, every step sends a signal through the skeleton, like a whisper through a web. The heel strikes the ground, vibrations travel upward through the leg, and the bones respond by thickening, strengthening, renewing. In space, there is no such conversation. The feet never strike the floor, the legs never carry a load. The web falls quiet, the silence spreads. Within weeks, the bones of the lower body begin to lose density at a rate far greater than any disease of age. What took decades on Earth can unfold in a single orbiting year. Calcium freed from bone does not vanish. It drifts into the bloodstream, turning the body's chemistry against itself. The kidneys, overwhelmed, filter constantly to remove the excess. Some of that calcium crystallizes into stones sharp enough to cut tissue from within. This is the unseen price of floating. Even the blood becomes a map of disassembly, carrying with it the minerals of a forgotten architecture. Researchers have tried to mimic gravity through machines that spin, vibrate, or pull. Some designs use rotating arms to create artificial weight through centripetal acceleration. Others employ harnesses and pulleys that pull the body downward against resistance. Yet no mechanism has perfectly replaced the continuity of Earth's pull. Gravity acts not in pulses but in permanence. It never switches off, never grants reprieve. Machines can imitate its strength, but not its constancy. The difference between temporary force and eternal pressure defines the challenge of space biology. The psychological dimension of this loss is harder to measure, but just as profound. Astronauts often describe the sensation of fragility, an awareness that beneath their calm exterior, something essential is fading. They become cautious, deliberate, aware that the smallest misstep could have unseen consequences. The knowledge that their bones are weakening alters the way they move, the way they think about motion itself. Gravity once gave them certainty. Its absence replaces that with hesitation. Every bone tells a different story of adaptation. The femur, built to bear the weight of walking, suffers most. The vertebrae, which once compressed slightly under gravity's load, begin to expand. The pelvis loses its density. reshaping its curve as if the body were preparing for a world where standing no longer matters. Even the skull changes subtly as fluids redistribute and pressure shifts within. The skeleton becomes a portrait of transformation, evolving in real time. In laboratories on Earth, scientists study these changes through models and simulations. Bed rest experiments, where volunteers lie flat for weeks, mimic aspects of weightlessness. Their bones thin, their muscles fade, their blood chemistry shifts, yet even in stillness, gravity continues to act on them. The comparison reveals how profound its absence truly is. In space, there is no reference, no downward pull to align the body's sense of structure. Without this axis, the skeleton loses its compass. There are moments when astronauts report feeling almost ethereal. Their limbs float lightly, their movements effortless, but the same grace conceals vulnerability. Without mass to resist, the muscles connected to bone begin to contract differently, tugging at joints that no longer carry force. Ligaments stiffen, cartilage changes texture. The geometry of the skeleton subtly deforms, adjusting to a new mode of being. It is not pain that signals the loss, but the eerie comfort of ease. The history of life on Earth is, in essence, the history of bone. From the earliest fish that developed internal scaffolds to resist the weight of shallow waters, to reptiles, mammals, and humans who learned to walk upright, the skeleton has always been gravity's most loyal apprentice. Each evolutionary step has been a dialogue with weight, each adaptation a compromise between mobility and strength. In space, that dialogue ends. Evolution's longest conversation falls silent. Even as technology evolves, the biological truth remains simple. The human body was never designed to exist in a state of continuous free fall. It can survive, it can adapt, but it cannot forget its origins. The bones of an astronaut in orbit still carry the memory of mountains, of pressure, of the endless negotiation between ground and sky. That memory cannot be erased, only paused. When gravity returns, so too does the story continue, though not without scars. For when astronauts step once again onto Earth, the skeleton greets the planet with both relief and rebellion. The first steps are heavy, uncertain. The bones, soft from disuse, feel the weight of 9.8 meters per second squared as shock. The joints compress painfully, the spine settles, and the body relearns how to stand. But this pain is proof of restoration. The sculptor's hand, patient and relentless, resumes its work. Recovery takes months, sometimes years. The bones rebuild slowly, guided by movement, nutrition, and time. Yet they never fully regain the density they once had. The memory of weightlessness lingers in their lattice, like a faint echo carved into stone. Each returning astronaut carries within their body a record of two worlds, one defined by gravity, the other by its absence. Their bones become chronicles of transition, fragile monuments to the limits of adaptation. And so, the unraveling of the skeleton tells a greater truth. Gravity does not simply hold life to Earth, it sculpts life into being. Without it, the structure weakens, not because of failure, but because structure itself is meaningless without pressure. In the silence of space, where weight is forgotten, the human skeleton reveals what it truly is. Not a rigid frame, but a living memory of Earth's pull, waiting patiently for the return of the force that made it whole. The skeleton's decline does not end with mineral loss. As the days in orbit stretch into months, the internal architecture of bone begins to change shape. Under a microscope, what was once a dense lattice becomes a fragile mesh, its branches thin and brittle. Spaces appear where there should be solid walls. The balance between compression and tension, so carefully calibrated on Earth, collapses. The bone no longer bears load. It endures only its own stillness. This weakening changes the way the body moves. In microgravity, no single step or motion tests the skeleton. Movement becomes a series of gentle pushes against air or walls, never the firm impact of foot against ground. Without that jolt of contact, joints lose their purpose. Knees no longer flex to absorb shock. Ankles no longer pivot to adjust balance. Even the spine, which evolved as a column of resilience, becomes an elastic rod stretching in quiet. Surrender. The consequence is subtle but profound. When astronauts return to gravity, they must relearn how to stand, how to walk, how to fall. Their legs tremble under the restored weight of their own bodies. Some describe the first steps as walking through water that presses upward from the ground. It is as if gravity itself were a physical presence, wrapping around them, pulling them back into its embrace with both gentleness and demand. This struggle reveals a universal truth about adaptation. The human body changes only as long as the environment demands it. In space, where resistance fades, so too does the structure built to oppose it. On Earth, gravity is a sculptor that never sleeps, pressing its lesson into the body with each moment of motion. When that teacher is gone, the student forgets. And when the lesson returns, it must be learned again from the beginning. To understand this process, scientists use advanced imaging to track bone density before, during, and after missions. They can see, slice by slice, how the loss begins at the microscopic level and grows outward. The vertebrae thin first, followed by the long bones of the legs. The pattern is consistent, predictable, and sobering. Even with 2.5 hours of daily exercise, astronauts can lose as much as 10% of their skeletal strength on long missions. The findings are clear. Gravity cannot be replaced, only imitated, and imitation has limits. Some researchers dream of artificial gravity as the ultimate countermeasure. A rotating habitat could generate a continuous downward pull through motion, creating a living environment where the body would once again feel pressure. But rotation brings its own challenges: disorientation, mechanical stress, and enormous energy costs. The idea remains more vision than reality. For now, astronauts rely on resistance training, diet, and determination. They become their own experiment, balancing between decay and endurance. Yet even in decay there is meaning. The skeleton's vulnerability in space exposes the interdependence of all systems. Bone loss triggers muscle loss. Muscle loss alters blood flow. Blood flow influences heart function. Each system reflects the absence of the same force, echoing the single truth that gravity is not an external condition, but an internal rhythm. To lose it is to rewrite the harmony of the body itself. In this light, the skeleton's unraveling becomes a kind of story, the story of a species daring to test its limits. It reminds us that strength is born not from ease, but from opposition. The human form, perfected through the demands of standing upright, walking, running, and falling, is a product of struggle. In space, that struggle ends, and with it, the sculpted resilience begins to fade. But the very act of confronting that loss gives new meaning to exploration. When astronauts gaze back at Earth from orbit, they see a world defined by gravity's hand. Mountains pushed upward, oceans drawn downward, air held close to the surface. They understand then that gravity is not the enemy of progress, but the measure of life itself. To live without it, even briefly, is to witness what happens when the foundation of being is lifted away. The skeleton is the body's memory of gravity, a structure written in stone and flesh. When that memory fades, the body does not die. It transforms, adapting to the void in ways that reveal both its fragility and its genius. Each returning astronaut carries that transformation within their bones, silent proof that life can endure the absence of its oldest companion, even as it yearns for its return. As the spacecraft glides silently above the planet, the crew moves through their daily rituals of exercise, maintenance, and study. Beneath their calm routines, their bones continue their quiet conversation with gravity's absence. They are not broken, only waiting. Waiting for the moment when the pull returns, when the pressure once again reminds them of what it means to stand. For the next stage of the journey is already beginning. As the skeleton weakens, the muscles that once served it begin their own slow collapse. The loss of one system calls upon the fall of another. Where bones fail, muscles follow, and the body, caught between adaptation and decay, must find new ways to remember the art of resistance. The body in space moves with elegance, yet beneath that grace lies quiet betrayal. Muscles that once strained against gravity's pull begin to lose their purpose. Each fiber, each strand that once carried the memory of weight, starts to forget. On Earth, every motion, every step, lift, stretch, or reach is a negotiation between effort and resistance. The constant pull of 9.8 meters per second squared gives meaning to strength. In space, where that resistance vanishes, effort becomes optional, and the body adapts to ease with alarming speed. The first muscles to fade are those that once stood guard against gravity: the calves, the quadriceps, and the long muscles of the back. These postural muscles are endurance engines built to hold the body upright hour after hour. In orbit, they have nothing to do. The legs no longer carry weight. The back no longer needs to stabilize the torso. The body floats in perfect equilibrium, and the quiet rebellion of muscle fibers begins. The slow twitch fibers, made for endurance, shrink. The fast twitch fibers, built for brief bursts of power, take over. The transformation leaves the muscles leaner, weaker, and quicker to fatigue. Astronauts often describe the first week in microgravity as liberation. Moving requires almost no effort. A push with a fingertip sends the body drifting across the cabin, graceful and weightless. But this grace conceals erosion. Without constant load, muscles no longer receive the microscopic tears that signal them to grow stronger. Protein synthesis slows, and atrophy follows. The change is measurable within days. Without exercise, an astronaut can lose nearly 20% of muscle mass in less than 2 weeks. In the void, stillness is decay. The heart, too, is a muscle, and it joins the rebellion. On Earth, it works against gravity with every beat, sending blood upward to the brain. In space, that uphill struggle ends. Blood distributes evenly through the body, and the heart's workload decreases. It begins to shrink, its walls thinning from lack of demand. What feels like relief is in truth a slow forgetting of strength. The heart learns a lighter rhythm, one that serves well in orbit but fails the moment gravity returns. Many astronauts experience dizziness or fainting upon landing, not from fear or exhaustion, but because their hearts have forgotten how to fight upward. To counter these effects, daily exercise becomes ritual. 2.5 hours every day, running on a treadmill held down by elastic harnesses, cycling against resistance, and straining against the advanced resistive exercise device that mimics lifting weights. Each motion is a deliberate act of defiance against the void. Sweat gathers and floats in perfect spheres before being drawn away by air filters. The sounds of breath and strain fill the station, echoing off its metal walls. The music of survival. Yet even these measures cannot fully preserve what gravity once gave freely. Exercise in space is an imitation, not replacement. The body knows the difference between constant weight and mechanical force. Gravity acts on every cell, every moment, without pause. Machines provide only fragments of that continuity. The result is that even the most disciplined astronauts return home weaker than when they left. The Sculptor's absence leaves marks that no machine can erase. Beyond the physical, there is a psychological dimension to this loss. Strength is identity. To feel muscles respond, to sense power in movement, is to feel alive. In space, the body's relationship to effort changes. Floating replaces standing, drifting replaces walking, and the absence of gravity erases the familiar sense of motion. The astronauts, though free, often describe feeling disconnected from their bodies, as though they are puppets whose strings have been cut. The act of pushing against nothing becomes strangely unsatisfying. Movement without consequence. Over time, the transformation reaches deeper layers. Muscles that once maintained posture now weaken, forcing others to compensate. Coordination shifts. The nervous system rewires itself to control a body that no longer knows where it belongs. Simple gestures, turning, reaching, even maintaining eye contact, require new calculations. The brain learns to move in 3 dimensions without the guidance of up or down. It is an elegant adaptation, but one that comes at the cost of the body's original design. Scientists studying these changes see the same patterns in bedridden patients and those confined by illness. The absence of movement and load leads to the same biochemical cascade: reduced protein synthesis, increased breakdown, insulin resistance, and altered circulation. Space, it turns out, is not merely a frontier, but a magnifying glass, showing in weeks what on Earth takes years of decline. The insights gained from astronauts now inform therapies for aging, recovery from injury, and long-term immobilization. The laboratory of the stars reflects the frailty of life below. Within the spacecraft, the struggle between adaptation and decay is constant. Every muscle contraction is both resistance and remembrance. The astronauts become their own experiment, human instruments measuring the limits of resilience. They learn to move efficiently, to control motion with the smallest impulses, to rely on precision rather than power. In that precision lies a strange kind of beauty. The floating human becomes a dancer of inertia, tracing invisible paths through the air, each turn a whisper of physics and biology intertwined. And yet, the knowledge of weakness remains. The muscles that once defined the human silhouette, the calves that lifted, the thighs that bore, the back that carried, fade quietly. Even the facial muscles change as fluids shift upward, altering appearance. The floating faces in orbit look different, softer, rounder, subtly unfamiliar. Gravity sculpts expression as surely as it sculpts bone, and in its absence, even identity shifts. There comes a moment, weeks or months into the mission, when the body accepts its new equilibrium. It no longer fights to preserve the old state. The muscles have adjusted to the reduced load, the joints have loosened, and the heart has recalibrated its rhythm. The astronauts can move effortlessly, their bodies perfectly tuned to the void. But adaptation has a price. What is gained in comfort is lost in endurance. The body built for Earth has become a creature of air, elegant but fragile, strong only in stillness. The return home exposes this transformation with brutal honesty. Re-entry compresses the body under the increasing force of gravity, and every muscle screams in protest. The calves cramp, the thighs burn, the heart races to push blood upward again. Standing feels unnatural. Walking feels like labor. The act of lifting one's own weight becomes a rediscovery of struggle. Astronauts describe it as learning to live in a heavier world. For them, gravity is no longer background. It is presence, pressure, and gift. The weeks that follow are filled with rehabilitation, resistance training, stretching, careful nutrition, and patience guide recovery. Slowly, the muscles remember their old rhythm. They thicken, they strengthen, they respond once more to effort. The sculptor's hand returns, reshaping the body through struggle. The pain is proof of life reawakening. In this cycle of loss and renewal lies the essence of the human story. We weaken without challenge, we grow through resistance. Gravity, constant and invisible, has always been that challenge, the unspoken partner in evolution. Spaceflight strips it away, revealing both the body's adaptability and its dependence. To lose gravity is to discover that strength is not an intrinsic state, but a dialogue with the forces that oppose us. As the astronauts walk again under open skies, their muscles trembling, they look upward toward the realm they left behind. They know now that the grace of floating came with a price. Strength is not freedom from gravity. It is the memory of its weight. And in that memory lies the truth of what it means to be human. Creatures shaped not by ease, but by the unending pull that keeps us grounded, balanced, and alive. The body remembers effort like a language, and in the silence of space, that language fades. Each muscle fiber is a word once spoken under the pressure of gravity, a phrase repeated through movement until it became instinct. On Earth, even the smallest gesture carries resistance. Reaching for a cup, climbing stairs, turning one's head, every act is a conversation between the muscles and the pull beneath them. In orbit, the conversation ends. The muscles grow quiet, and silence becomes decay. At first, the change is subtle. The calves soften, the thighs lose their spring, the back no longer holds its proud tension. The body feels lighter, but this is an illusion born from deprivation. Without gravity, muscles are unemployed. They drift through their own stillness, unaware that every moment of comfort is a moment of loss. The absence of struggle feels like peace, yet peace is the slowest kind of surrender. Inside each muscle cell, the machinery that builds strength begins to shut down. Protein synthesis decreases, mitochondria reduce their energy output, and the fibers shrink. Enzymes that once supported endurance are replaced by those meant for quick, inefficient bursts of energy. The body is economizing, rewriting itself to fit an environment that no longer demands effort. The transition is silent but relentless. Within weeks, the strong legs that once carried a person through life become as fragile as those of someone confined to bed for months. The astronauts, disciplined and aware, fight back with routine. Each morning, they tether themselves to the treadmill, pulling down with elastic harnesses to mimic weight. They cycle against resistance, feeling the straps bite into their shoulders as they force their muscles to remember work. Sweat gathers and floats, caught by the hum of the ventilation system before it can drift into equipment. The exercise becomes meditation, a ritual that separates those who endure from those who decline. In this daily strain lies a memory of home, the memory of standing, of falling, of being bound to earth. Still, the environment wins in small ways. The shoulders broaden as astronauts use their arms for movement more than their legs. The body, freed from vertical posture, begins to resemble a swimmer's, a shape tuned for fluid motion rather than weight-bearing strength. The lower body thins, the calves narrow, and the spine elongates. Even the heart, floating within the chest, shifts position slightly, suspended in balance rather than anchored by gravity. The human form, once sculpted for the ground, becomes a design for the void. What fascinates scientists most is how quickly the body accepts this transformation. The nervous system, the master conductor, rewires itself to match the new reality. Muscles that once worked in opposition now work in coordination. Movements become graceful and efficient, as if the body has always known how to swim through air. But beneath that elegance lies fragility. When the astronauts return to gravity, that delicate coordination fails. Muscles that adapted to freedom collapse under the old burden of weight. The same brain that once learned to float must now relearn how to stand. The weakening of the heart mirrors this pattern. It no longer pumps with the urgency demanded on Earth. Without gravity pulling blood downward, circulation evens out. The heart becomes smaller, rounder, more relaxed. It works efficiently in the new environment, but at a cost. The moment gravity returns, the heart struggles to push blood upward. Many astronauts faint after landing, their bodies unable to adjust to the sudden return of resistance. This temporary failure is not a flaw, but a memory of survival in another world. In space, the loss of muscle strength also changes how astronauts experience time. Effort becomes measured not in distance or weight, but in persistence. A session on the treadmill is not about covering kilometers. It is about proving existence against entropy. The repetitive rhythm of exercise becomes the heartbeat of life in orbit. Each step, each pedal stroke, is a declaration that the body will not surrender its heritage to the void. Still, the muscle fibers tell a different story. When analyzed after flight, they reveal signs of cellular fatigue. The cross-sections of the fibers shrink, the mitochondria cluster unevenly, the capillary networks thin. The change is not catastrophic, but it is profound, a quiet reminder that the body was not made for idleness. Scientists study these samples, learning how to slow the process, how to trick the body into believing that gravity still exists. Yet even the most advanced countermeasures cannot replicate the constant dialogue between body and world that life on Earth provides. Psychologically, this decline carries a strange duality. The astronauts feel powerful in the weightless environment, able to move effortlessly in all directions. But that freedom hides dependence. They know that every motion is made possible by the very absence that weakens them. The paradox is haunting. Strength born of weakness, grace born of decay. They exist in a state where motion feels like flight, but physiology whispers of collapse. Outside the spacecraft, the Earth turns in silence, glowing beneath the sunlight. From orbit, it looks eternal, yet the astronauts know that its pull is the source of all their strength. In microgravity, they have become testaments to adaptation, living experiments that reveal the limits of human design. The muscles that once defied gravity now float aimlessly, waiting for a challenge that never comes. And so, the body changes not out of failure, but obedience. Obedience to physics, to biology, to the quiet truth that form follows need. Every day the astronauts stretch and pull against invisible walls, defying the ease that surrounds them. Each heartbeat becomes an act of remembrance. They know that gravity is more than a force. It is a teacher. Without its lessons, the body grows silent. Without its resistance, strength dissolves into memory. Yet even as they weaken, they understand the purpose of this journey. To lose strength in space is to learn what gives it meaning on Earth. In that understanding lies the essence of exploration. It is not conquest, but communion. A dialogue between life and the universe that tests the limits of both. The muscles may fade, but knowledge grows. Through their decline, humanity learns what must be preserved, what must be reinvented, and what must never be taken for granted. The sculptor may be absent, but its signature remains, written in every fiber that still remembers the weight of home. In the stillness of orbit, every movement becomes poetry. The body, once bound by weight, now floats through its own undoing. Muscles that had defined the human form, those chords of motion, strength, and will, are now the most visible evidence of transformation. Their purpose has changed. They are no longer tools of endurance but instruments of control, guiding motion through gentle touch and breath. Yet with each effortless glide, the body drifts further from the memory of gravity's rhythm. On Earth, every contraction and extension of muscle carries the story of struggle. A leg pushes against the ground, the back stiffens to maintain posture, the arms lift in defiance of the planet's pull. Every movement is dialogue, every gesture a rehearsal of resistance. In space, that dialogue fades. The muscles that once sang in harmony with the bones now whisper quietly in the absence of need. What once was necessity becomes choice. The body, relieved of its labor, begins to reshape its own priorities. Deep inside each cell, the biochemistry of effort changes. The energy factories, mitochondria, no longer multiply to meet constant demand. Instead, they shrink and reorganize, reducing output to match the new reality. The molecules that once signaled growth and repair slow their dance. The bloodstream carries fewer amino acids toward muscle fibers, and the scaffolds of strength begin to thin. The change is invisible to the eye, but the consequences are profound. The body, left without its lifelong adversary, turns from warrior to observer. For the astronauts who live this transformation, awareness comes gradually. At first, the ease of movement feels intoxicating. No more aching joints, no more tired legs after long hours. But as weeks turn to months, subtle reminders emerge. A failed grip, a weak push, a delayed response. Muscles no longer obey instinctively. They pause between intention and action, as if asking for confirmation. The body that once knew motion without thought must now relearn it step by step. To preserve what they can, astronauts follow their exercise rituals with devotion. The machines, the treadmill, the bicycle, the resistive trainer, become extensions of survival. They are not simply tools, they are substitutes for a missing planet. Each pull on a resistance bar, each press against a pedal, is a symbolic return to Earth. The exertion reawakens the body's memory of gravity, if only for moments. Heartbeats quicken, blood surges, oxygen burns through the lungs, echoes of a world left behind. Even so, adaptation moves faster than preservation. The human body is loyal to its environment. It learns not through intention, but through necessity. Without true weight, the feedback loops that maintain strength falter. Sensors in muscles and tendons, tiny receptors that measure load, stop firing. The brain receives no message of effort, no command to rebuild. It interprets the quiet as completion. And in that miscommunication, strength becomes unnecessary. Scientists observing from Earth see this as both tragedy and revelation. The same systems that betray astronauts in orbit reveal how exquisitely tuned the body is to gravity. Evolution did not simply make humans adaptable, it made them dependent. Muscle tone, endurance, and coordination all rely on the presence of weight. Remove it, and the intricate design of motion begins to blur. Yet within that blurring lies knowledge, a new understanding of how life writes its structure in response to the physical world. The emotional toll of this decline is harder to quantify. Astronauts are aware of their own diminishing strength. They watch their legs thin, their arms lose firmness, their grips soften. It is not vanity that troubles them, but identity. Strength has always been part of being human, not merely as power, but as proof of purpose. To lose it, even temporarily, feels like drifting away from humanity itself. In the mirror of the spacecraft window, the reflection looking back is familiar, yet changed, a reminder that even the most disciplined spirit cannot escape the physics of adaptation. Yet there is beauty in this fragility. The muscles, though weaker, become symbols of endurance in another sense. They demonstrate that life will always adapt, even in the most unnatural of environments. The same fibers that once lifted mountains of effort now learn to float through silence. They find a new equilibrium, trading power for precision, strength for grace. The body becomes a new instrument, not less capable, but differently attuned. And when the journey ends, when the spacecraft turns toward home, the return to gravity feels like resurrection. The first breath of heavy air, the first pull of the planet beneath the feet. Each sensation is overwhelming. The muscles strain, ache, and tremble, but the pain is welcome. It is the sound of gravity's music returning. The body, after months of forgetting, begins to remember its old rhythm. Each step on solid ground is a conversation resumed, a familiar struggle rediscovered. Rehabilitation becomes a sacred ritual. Astronauts rebuild strength slowly, guided by trainers and physicians. They walk in harnesses, lift light weights, stretch tendons that have forgotten tension. The process is measured in patience, in small victories, a longer stride, a stronger pulse, a steadier stance. Over weeks, the body reclaims its form, as if gravity itself was sculpting once more. But even after recovery, something fundamental remains changed. Those who have floated in the absence of weight never again take it for granted. They speak of the joy of heaviness, of the miracle of effort, the simple act of lifting a cup, the pressure of feet against the floor, the tug of air in the lungs, all become reminders of connection. They understand now that gravity is not an obstacle, but an embrace, that to resist it is to live fully within it. The lesson of the muscles is the lesson of all life on Earth. Strength is born not from the absence of struggle, but from its constancy. The pull that once seemed to hold humanity down is, in truth, the force that raises it up. Every step, every heartbeat, every act of endurance is a conversation with that pull. Space, in taking it away, has revealed its meaning. As the astronauts look up at the sky after their return, their muscles renewed, but still remembering the weightless world, they understand that gravity is not a prison from which they escaped. It is the silent teacher that shaped them, the unseen hand that gave them strength, and the promise that no matter how far they travel, they will always belong to the world that taught them how to stand. The first thing to change in orbit is not the bone or the muscle, but the blood. Within minutes of leaving gravity behind, the body's internal tides begin to rise. On Earth, every heartbeat works against the downward pull, keeping blood from pooling in the legs. Veins carry it upward through valves that open and close in rhythm with motion, guided by the constant tug of weight. But in space, where there is no up or down, no direction of flow, the blood forgets where to go. It drifts toward the chest and the head, a quiet flood of life seeking equilibrium in a world without direction. The astronauts feel it first as pressure behind the eyes. Their faces puff slightly, their cheeks round, their neck veins stand out as if sculpted beneath the skin. They laugh at one another, swollen, wide-eyed, looking like caricatures of their Earth selves. The phenomenon becomes known as the puffy face and bird leg syndrome. The head is full, the legs thin, the balance of fluids reversed. In the absence of gravity, blood no longer obeys. This fluid shift is not merely cosmetic. It changes how every organ functions. The brain, now bathed in excess fluid, senses danger. Pressure builds behind the eyes, distorting vision and bending the delicate shape of the retina. Some astronauts return home unable to see clearly, their sight permanently altered by months of microgravity. The sinuses swell, the sense of smell dulls. The inner ear, already disoriented by the lack of gravitational reference, joins the rebellion, amplifying nausea and confusion. Inside the chest, the heart begins to adapt. It no longer needs to push blood uphill. The effort that once defined its strength becomes unnecessary. Like any efficient machine, it responds by scaling back. The walls of the left ventricle thin, and the overall volume of the heart shrinks. In orbit, this is a form of equilibrium, the organ working precisely as much as it needs to. But equilibrium is treacherous. When astronauts return to Earth, this smaller heart must suddenly face gravity's demand again. Blood sinks to the legs, and the weakened heart cannot immediately compensate. The result is orthostatic intolerance, dizziness, fainting, and an overwhelming sense of collapse upon standing. Researchers studying these effects use experiments that seem almost ritualistic. They place astronauts in tilt tables that simulate the angle of standing. They use cuffs around the thighs to trap blood, mimicking the weight of gravity. They record heart rates, blood pressure, and oxygen levels as the body relearns how to stand. It is humbling to witness how fragile balance truly is. A force invisible yet constant on Earth defines whether one stands tall or falls fainting to the ground. Beyond physiology lies the deeper symbolism of the heart's adaptation. The same organ that has always fought to send blood upward, that rhythmic engine of defiance, now drifts in a world where nothing rises or falls. Its beat continues, but its purpose shifts. The heart becomes not a fighter, but a drifter, circulating life in circles rather than against resistance. Even emotion seems to echo this change. Astronauts often describe a strange calmness in space, a detachment that borders on serenity. Without the familiar sensation of pressure in the chest, even the heartbeat feels quieter, as if the body itself is meditating. But serenity has its price. The body begins to lose not just physical but emotional feedback. On Earth, we feel our hearts most when they labor, during fear, effort, or love. The pounding against the ribs is proof of life. In microgravity, that pounding softens. The heart no longer presses against bone. It floats freely, and in that freedom, it forgets the weight of feeling. Some astronauts, upon returning, speak of missing that sense of heaviness. Not the exhaustion of strain, but the pulse that connects effort to emotion. The redistribution of fluids also affects the brain. Cerebrospinal fluid, which cushions and nourishes the nervous system, rises slightly in pressure. The delicate balance between brain and body shifts. This may contribute to the cognitive fog that astronauts sometimes experience. A slowing of thought, a brief hesitation in reaction, as if the mind itself were floating. The boundary between physical and mental dissolves in microgravity. The fluid that moves through veins and ventricles becomes both a messenger and a mirror, reflecting how deeply gravity anchors not only the body, but consciousness itself. Even breathing changes. Without gravity's help to pull the diaphragm downward, the lungs fill differently. Air does not settle in the lower lobes as it does on Earth. Gas exchange becomes less efficient, and the sense of depth in each breath diminishes. The rhythm of respiration adjusts, slower, shallower, yet steady. The body finds a new pattern, proof of its ability to adapt, even when the fundamental rules have changed. From outside, watching through the small round windows of the spacecraft, the Earth appears serene. Oceans swirl in blue spirals. Clouds stretch across continents in endless motion. Gravity keeps it all in place. The same force that once pulled at the blood now holding entire worlds together. The astronauts, suspended in its orbit, are not beyond it, but within its reach, circling in obedience even as they study its absence. They understand now that gravity's work does not end at the surface. It defines every beat of the heart, every breath, every shift of fluid that sustains life. Without it, the body becomes a new kind of vessel, elegant but precarious, functional yet vulnerable. The heart still beats, but it beats in a silence so profound that it seems to echo across the void. In the long silence of orbit, the heart begins to change, not only in shape, but in spirit. It beats with the same rhythm, but the meaning of that rhythm shifts. On Earth, every contraction sends blood against gravity's resistance, an act of defiance repeated billions of times in a lifetime. In space, that defiance fades. The heart still moves, but not against anything. It floats within the chest, suspended, its work suddenly effortless. It is the first organ to truly experience what freedom from struggle feels like. And it is that freedom which quietly weakens it. The redistribution of fluids gives rise to strange sensations. The astronauts describe the fullness in their heads as though they are hanging upside down, a pressure that refuses to fade. They feel congested, their sinuses swollen, their voices nasally altered. Even tears, when they come, do not fall. They cling to the eyes in perfect spheres, magnifying light and emotion alike. In this world without direction, gravity's absence turns even crying into an experiment. There is no downward path for sorrow to follow. It simply hovers, waiting to be collected. Inside the chest, the floating heart adjusts to a new physics. Its chambers no longer fill and empty in the same proportions as on Earth. The atria expand slightly, blood lingers longer between beats, and the reflexes that regulate pressure and volume lose their reference points. On Earth, standing up or lying down triggers instant adjustments. Vessels constrict, heart rate changes, equilibrium restores. In space, where position is meaningless, those reflexes go quiet. The body learns to operate without the signals it has trusted for millions of years. This recalibration comes at a cost. The baroreceptors, the sensors in arteries that monitor blood pressure, grow less responsive. When the astronauts return home, the simple act of standing can send them collapsing into dizziness. Their bodies, having forgotten the need to fight gravity, fail to send blood to the brain quickly enough. Some faint upon stepping out of the capsule, their hearts momentarily overwhelmed by the reawakened demand. These moments are not weakness, they are evidence of adaptation. The body has mastered another world and must now remember its own. In laboratories on Earth, researchers replicate these conditions with remarkable precision. Volunteers lie for weeks with their heads tilted slightly downward, mimicking the fluid shift of spaceflight. Within days, their faces swell, their legs thin, and their hearts begin to show the same signs of adaptation. Scientists measure how quickly blood redistributes, how heart size changes, how reflexes dull. Each finding confirms the same truth. Gravity's absence is not passive. It is a constant, active force shaping physiology even through its removal. The deeper one looks, the more astonishing the connection becomes. Gravity determines not only where blood flows, but how it flows. On Earth, it pulls red blood cells toward the lower body, shaping circulation patterns and oxygen delivery. It influences kidney function, hormone secretion, even the rhythm of urine production. In space, all of these cycles change. The kidneys sense excess fluid near the upper body and respond by producing more urine, causing dehydration over time. The thirst response fails to compensate, and hydration must be meticulously managed to avoid strain on the heart. Each adjustment reveals another layer of the body's dependence on direction. And yet, the human organism endures. Within weeks, a new equilibrium emerges. Blood volume stabilizes at a slightly lower level. The heart's output adjusts to match the reduced demand. The system becomes efficient again, different but balanced. The body, that master of adaptation, finds harmony even in the void. The irony is that this harmony cannot last once gravity returns. What serves as balance in space becomes imbalance on Earth. Adaptation in this context is a double-edged triumph. Beyond physiology, there is poetry in these transformations. The floating heart becomes a symbol of both vulnerability and resilience. It beats in silence, held aloft by nothing, proof that life does not need to be anchored to endure. And yet, its very survival depends on the memory of what it has lost. The heart was shaped to fight weight. Its purpose was forged through resistance. To float freely is to lose part of that identity. The astronauts understand this paradox intimately. They are explorers of both outer and inner space, watching their own biology evolve before their eyes. When they speak of their experiences, they often describe a sensation of internal expansion, a strange awareness of their heartbeat, as if it fills their entire body. Without gravity pressing blood downward, the pulse is felt evenly, softly, in every direction. The body becomes a resonant chamber for its own rhythm. Some astronauts say it feels like being suspended inside one's own pulse. It is a form of meditation enforced by physics, a reminder that the body too is a planet, with tides, currents, and orbits of its own. From this vantage, the heart ceases to be a mere pump. It becomes a living metronome, marking time in a universe where time itself feels fluid. Its beats are the measure of both existence and endurance, each one echoing across the void as testimony to life's persistence. Even as it weakens, it remains steadfast, adjusting, adapting, and reminding its host of what it means to live within balance, whether under gravity's hand or beyond it. Outside the station, Earth glows silently below, a sphere of water and motion. Its tides rise and fall, its clouds swirl, its oceans breathe in time with the moon. The same gravitational rhythm that moves the seas beats within every human chest. To see the planet from above is to understand this unity, that the pulse of the heart and the pull of the earth are not separate, but one continuous conversation written across scales of magnitude. The astronauts drift in that conversation, halfway between belonging and departure, their hearts floating but faithful to the rhythm that began long before them. The longer one remains in space, the more deeply the body learns to live in the new equilibrium. What began as confusion becomes familiarity. The heart, once restless in its floating chamber, settles into its new rhythm. Blood no longer surges against gravity, but circulates in soft, continuous currents. The body no longer asks which direction is up, because direction itself has ceased to matter. In this quiet surrender, humanity witnesses what adaptation truly means. Not resistance, but acceptance. The redistribution of fluid reaches even the smallest vessels. Capillaries, which once relied on pressure gradients to push oxygen and nutrients into tissues, now work in near-perfect symmetry. Without gravity, flow equalizes across the body, yet perfection brings peril. The constant headward pressure can distort vision, stretch tissues in the eyes, and alter the delicate geometry that focuses light. Many astronauts return home with a subtle blurring of sight. The world appears slightly different, as if seen through the memory of stillness. Scientists call this spaceflight-associated neuroocular syndrome, but to those who experience it, it feels like the eyes themselves have been reshaped by the absence of weight. Even taste changes. The swelling of facial tissues dulls the sense of flavor, flattening the joy of food. Astronauts crave spice and heat, anything sharp enough to pierce the haze of fluid in their sinuses. Meals that once seemed rich become bland, reminders of the body's quiet revolt. In this way, even eating becomes a ritual of adaptation, a negotiation between what is remembered and what is possible. The cardiovascular system, too, continues its conversation with the void. The blood's composition changes slightly, its plasma volume decreasing as the body sheds what it no longer needs. Hematocrit levels, the ratio of red cells to fluid, rise temporarily, only to settle again as the body recalibrates. The result is a kind of illusion, a leaner, more efficient circulation that functions well in microgravity but hides its fragility. When astronauts return to Earth, this lean system must suddenly expand to meet the demands of gravity, and for days or weeks it struggles to do so. Their hearts race with the effort, and many speak of feeling lightheaded or hollow, as though gravity itself were pulling something from within. During long missions, doctors on Earth monitor heart rate, blood pressure, and hydration through telemetry, a silent lifeline of data. Each number tells a story of balance, not only physical, but emotional. Stress, excitement, exhaustion, and awe all leave traces in the pulse. In space, these emotions merge. The astronauts' hearts respond not to weight, but to wonder. When they look out the window and see their home world spinning silently below, their heart rates often slow, entering a rhythm close to meditation. It is as though the heart recognizes the view, as if in that instant it feels gravity again, not as pull, but as belonging. Yet the body never stops longing for the stability of Earth. Even after months of adaptation, small reminders of gravity's absence persist. Tiny bubbles of air in the bloodstream, usually harmless, now behave differently. The body's natural mechanisms for dispersing them rely on the downward pull of weight. Without it, astronauts must move carefully to prevent discomfort. The blood itself, in its constant drifting, becomes an emblem of suspension. Life moving without destination, endlessly circulating within its vessel, much like the spacecraft orbiting the planet below. This endless circling transforms more than the body. It reshapes perspective. The astronauts begin to see gravity not as an enemy conquered, but as a connection sustained. They orbit not to escape its reach, but to remain within its dialogue. Each rotation of the spacecraft is a silent return, a constant falling toward Earth that never completes. Even here, weightlessness is an illusion. The astronauts are always falling, together with the station, together with the planet, bound by the same invisible thread. When the mission ends and re-entry begins, that thread tightens. The first sensation of gravity's return is not sight or sound, but weight pressing inward. A reminder that home has mass. The fluids that once drifted freely sink back toward the legs. The heart quickens, its chambers stretching under renewed demand. The face slims, the legs swell. The internal tide reverses, and the body rediscovers direction. For some, it is a painful reunion. For others, it is a homecoming of the soul. Upon landing, the simple act of standing becomes profound. Blood races to the legs, and the head feels briefly empty, like a vessel suddenly drained. The heart, stunned but determined, relearns its duty within minutes. Each beat grows stronger, each breath deepens. The balance between effort and ease returns, and with it, the familiar pressure that defines life on Earth. Astronauts often describe this moment not as burden, but as gratitude. They feel gravity not as pull, but as presence, the invisible touch that reminds them they belong to something vast and constant. The floating heart, now heavy once more, becomes a symbol of endurance. It has endured stillness, imbalance, and transformation, and in doing so, it has revealed the truth of life's design. Strength is not static. It is the ability to adapt and return. In the vacuum of space, the heart learned how to drift. On Earth, it learns again how to struggle, and through struggle, how to live. Every heartbeat is now an echo of two worlds, one of stillness, one of gravity. The memory of floating remains, a quiet pulse within the chest, reminding the astronauts that freedom is not the absence of weight, but the understanding of it. The sculptor's hand may have lifted for a time, but its influence endures in every cell, every rhythm, every drop of blood that continues its eternal fall toward balance. As they look once more toward the sky, they know that the journey of adaptation never ends. The body may return to gravity, but the memory of weightlessness stays within, whispering of a place where the heart was light enough to float and strong enough to remember how to fall. When gravity disappears, the body is not the only thing that must relearn how to exist. The mind, too, begins its slow unraveling. In orbit, there is no up or down, no floor or ceiling. The senses that once mapped direction, balance, and stability are left without their ancient guide. Inside the skull, the vestibular system, that delicate labyrinth of fluid-filled canals, drifts into confusion. On Earth, it measures acceleration and tilt through the movement of fluid across tiny hair cells. In space, that fluid floats aimlessly, sending contradictory signals to the brain. The result is disorientation, a feeling of tumbling in every direction at once. At first, the brain refuses to believe what it experiences. The eyes insist that the body is still, but the inner ear declares motion. This conflict births what is known as space motion sickness, a condition as old as flight itself, but magnified in the void. Astronauts feel nausea, dizziness, and a heavy pressure within their skulls. Some cannot eat, others struggle to focus their eyes. The body that once trusted its own senses must now doubt them. Yet, just as it does with muscles and bones, adaptation begins. The brain, astonishingly flexible, rewrites its code. Within days, it learns to ignore the signals of the inner ear, to trust vision alone. The sickness fades, replaced by a strange serenity, a new equilibrium in the absence of gravity. This adaptation reshapes perception itself. Without the constant reference of weight, orientation becomes a matter of decision. The human brain, which evolved to define space by verticality, now constructs direction from context. The ceiling can be the floor can be a wall. Astronauts rotate freely, choosing what feels like down based on convenience. Their minds accept the change as though it were always natural. Yet this freedom from direction comes at a cost, the loss of a fundamental psychological anchor. On Earth, gravity provides not just balance but purpose. Up means aspiration, down means rest. In orbit, those meanings dissolve. Time, too, loses its structure. The International Space Station circles the Earth 16 times every 24 hours. Day and night alternate every 90 minutes, flooding the cabin with light and darkness in rapid succession. Circadian rhythms, tuned to the slow turning of the planet, begin to fracture. The hormones that regulate sleep and alertness fall out of sync. Melatonin declines. Cortisol surges unpredictably. Astronauts drift between wakefulness and exhaustion, their minds suspended between day and night. They follow scheduled cycles dictated by mission control, but their bodies never fully believe the artificial rhythm. Dreams become vivid, fragmented, filled with motion and silence. The subconscious, deprived of normal cues, invents its own gravity. In this altered world, cognition changes in subtle ways. The brain, no longer anchored by gravity, devotes more energy to spatial awareness. It must calculate movement in 3 dimensions rather than 2, anticipating not only forward and back, left and right, but up and down without reference. This continuous recalibration consumes mental resources. Astronauts report slower reaction times, brief lapses in attention, and a fog that dulls the sharpness of thought. Some call it space brain, a gentle haze that settles over consciousness, not debilitating but persistent. Scientists attribute it to fluid redistribution within the skull and altered blood flow, but there may also be something deeper at work. The human mind, it seems, resists existing in a place without orientation. Yet amid the confusion, the brain begins to evolve new strategies. Vision takes command, using light and shadow to construct virtual gravity. Objects become landmarks of orientation: a panel, a handrail, a reflection. The mind builds its own map of stability within chaos. This adaptation is not just neurological, but philosophical. It demonstrates the essence of intelligence, the ability to find meaning in an environment where meaning has been stripped away. The brain learns to navigate a world where there is no down to fall toward, no ground to rest upon. And in doing so, it discovers a new form of freedom. The psychological effects extend beyond perception. Isolation, confinement, and distance press upon the mind with invisible weight. The stars, so bright from below, become silent companions that offer no warmth. Communication with Earth is delayed, the voices of loved ones arriving seconds too late, echoing through digital static. Time on Earth moves forward. Birthdays pass, seasons change, but the station's environment remains unchanged. The sameness becomes a test of endurance. Astronauts describe moments of deep introspection, of realizing how fragile their sense of self becomes without the external markers of change. Some find solace in routine, others in the simple view of Earth, always turning, always alive. That view, of home from above, exerts a profound psychological force. It induces what scientists call the overview effect, a cognitive shift in which astronauts experience overwhelming unity with the planet below. The borders between nations vanish, the divisions between people seem absurd, and life itself appears as a single phenomenon suspended in darkness. Many who experience it describe tears floating from their eyes as they gaze upon the blue sphere, not from sadness, but from awe. The mind, having lost its physical center, finds a spiritual one. The brain's adaptability is both blessing and burden. It allows survival in the void, yet it blurs the boundaries between reality and perception. Some astronauts report losing track of orientation, even after weeks of adaptation, a slow tumble that exists only in thought. Others experience phantom sensations of gravity, feeling the illusion of weight on their limbs while floating freely. The mind creates its own gravity when deprived of the real thing, proving that even in absence, the brain refuses emptiness. There are moments, especially during solitude, when perception becomes almost mystical. The constant hum of ventilation and the soft vibration of machinery form a background rhythm, like a mechanical heartbeat. The faint tug of inertia from the station's rotation gives the illusion of motion within stillness. In these moments, astronauts describe feeling both immense and insignificant, a consciousness untethered from body, floating between thought and space. The brain, deprived of gravity's grounding, reaches inward for meaning. When the mission ends and re-entry begins, the mind must once again relearn the world of weight. Gravity's return is not gentle. The vestibular system, long dormant, awakens in chaos. The first tilt of the capsule reawakens the old reflexes. The inner ear sends signals the brain no longer knows how to interpret. Vertigo floods the senses. Upon landing, even standing still feels like motion. The world sways, the ground pulses, the eyes struggle to fix upon stable points. It takes days, sometimes weeks, for balance to return, for the mind to trust the body again. But the deeper transformation never fades. Astronauts who have lived without gravity often speak of permanent shifts in perspective. The boundaries between inner and outer space blur. Their sense of belonging expands beyond geography, beyond nationality. They carry within them the memory of floating, not as freedom, but as understanding. They have seen that gravity is not merely a force, but a language through which the universe speaks to the body and the mind alike. On Earth, when they lie awake at night and feel the weight of their own bodies pressing against the bed, they no longer think of it as burden. They think of it as connection. The pressure of gravity, the pull of the planet, the heaviness of existence, all become reminders of being home. They have learned that the mind, like the heart, needs weight to define itself. Without it, thought drifts endlessly, untethered. With it, consciousness finds balance, meaning, and direction once more. The return to gravity is, therefore, not an ending, but a reunion. The mind, which once floated through uncertainty, rediscovers its foundation in weight. The inner ear sings again, the senses align, and the brain relearns the comfort of knowing where down truly is. Yet within that rediscovery lingers a quiet awareness that up and down are illusions of perspective, and that gravity, like thought, is simply the universe reminding us where we belong. Aging is the slow negotiation between life and gravity. Every moment on Earth, the pull of weight shapes the body, compressing the spine, wearing down joints, tugging gently on skin and muscle. It is both sculptor and thief. In space, when that pull vanishes, something remarkable happens. The process of aging seems to change direction. The absence of gravity removes one kind of strain but replaces it with another, subtler one that reaches all the way down to the level of the cell. Inside the human body, time is written in code. The ends of chromosomes, called telomeres, shorten with every division, marking the passage of life. During NASA's twin study, one brother on Earth aged under gravity's rule, while the other, Scott Kelly, drifted in microgravity for nearly a year. To everyone's surprise, his telomeres lengthened during flight, as though time had loosened its grip. Yet when he returned to Earth, they rapidly shortened again. The body, it seemed, stretched time only temporarily. Microgravity paused one kind of aging but accelerated another. Cosmic radiation, the invisible sea that fills the space between stars, bombards every astronaut's body. On Earth, the atmosphere shields us. In orbit, that protection thins. High-energy particles slice through cells, leaving trails of damage in their wake. DNA repairs itself constantly, but the balance between damage and healing tips toward wear. The very act of drifting free of gravity exposes the body to the true age of the universe. Radiation, relentless and ancient, writes its signature in every genome it touches. Other systems join this strange paradox. The immune system weakens, its soldiers slower to respond. Wounds heal sluggishly, inflammation lingers. Muscles and bones, deprived of resistance, mimic the decline of advanced age even in the young. In orbit, a 30-year-old body can resemble that of an elderly one after only a few months. The posture of weightlessness is the posture of age, floating, bent, fragile. Yet within this fragility lies resilience. Exercise, nutrition, and discipline slow the unraveling, teaching the body to balance decline with adaptation. The brain also shows hints of aging in orbit. The stress of confinement, altered sleep cycles, and radiation together create a subtle cognitive fog. Memory falters slightly, reaction times lengthen, and emotions flatten. Scientists studying these effects see echoes of terrestrial aging. a rehearsal of senescence sped up by distance. But unlike on Earth, astronauts are aware of every change, observing their own transformation with scientific precision. They are both subjects and witnesses of their evolution. And yet, even here, gravity's absence grants a strange mercy. Without compression, spines elongate. Astronauts grow several centimeters taller. Joints, freed from decades of grinding, rest. The body floats, unburdened by its own mass. Some describe this as feeling young again, their movements light, their pain dissolved. The mechanical aging slows even as the biological one accelerates. It is as though the body trades one kind of youth for another. This paradox forces a deeper reflection. On Earth, aging feels like a downward journey, the slow surrender to weight. In space, it feels like suspension, the drift between vitality and decay. Neither is escape. The universe allows no perfect stasis. Even here, cells divide, DNA frays, and the clock of entropy ticks on. Time is not measured in years or orbits, but in the persistence of adaptation. When astronauts return, they bring with them not only weakened bones and tired muscles, but altered genes and a new understanding of mortality. They have seen how fragile life is when stripped of its familiar pressure. Yet they also carry proof of endurance, that even in the harshest environment, the body finds ways to repair, to remember, to persist. Gravity ages us by wear. Its absence ages us by loss. Between the two lies the truth of life's balance. Back on Earth, as they stand once more under full weight, astronauts feel the pull of time differently. The ache in their joints, the heaviness in their chest, the slow rhythm of their pulse, all reminders of home. They understand now that gravity, though it drags us toward the ground, also gives our lives direction. Aging in orbit shows that what wears us down also keeps us whole. To grow old under gravity is not defeat, it is belonging. The dream of creating gravity where none exists is as old as spaceflight itself. Engineers and scientists know that the body cannot endure endless weightlessness. Muscles fade, bones dissolve, hearts shrink, and minds drift. To solve this, humanity imagines building gravity anew, not through mass, but through motion. Artificial gravity is the hope of restoring the familiar pull in a place that has none. The idea is elegantly simple and physically profound. If a spacecraft spins, the centrifugal force pushes everything inside toward the outer wall. What feels like weight is really motion, the body pressing outward as the ship turns. The faster the rotation and the wider the radius, the stronger the sensation of gravity. But perfection lies in balance. Spin too slowly, and the illusion fails. Spin too fast, and the body senses conflicting forces, inducing dizziness and confusion. The threshold is narrow, about 1 revolution every minute for a structure hundreds of meters wide to simulate the pull of Earth. This concept has long inspired visionaries. Stanley Kubrick imagined it in 2001, A Space Odyssey, where astronauts jogged along curved corridors, their footsteps ringing on the inside of a rotating wheel. NASA and other agencies have studied similar systems for decades, from compact centrifuges that spin a single astronaut to vast rotating habitats that might one day orbit the Moon. Each design confronts the same challenge: to mimic nature's most fundamental force without its source. Short-radius centrifuges already exist on experimental modules. Astronauts strap into them for minutes at a time, spinning gently to trick their bodies into remembering pressure. The blood shifts, the bones feel stress again, and for a brief moment the body believes it has returned home. Yet such machines cannot replicate the continuous embrace of real gravity. They are reminders, not replacements. The greatest obstacle is not technology, but biology. The inner ear, so easily disturbed in microgravity, rebels against artificial spin. Even small rotational differences between head and feet can cause severe disorientation. Engineers propose solutions: adjustable speeds, alternating spin directions, gradual acclimation. But the body's ancient instincts resist. It has evolved under one kind of gravity, steady and constant, and any imitation feels imperfect. Despite the difficulty, humanity persists in this pursuit because artificial gravity represents more than survival. It is a declaration of intent that we will carry the essence of Earth wherever we go. The rotating space station, the spinning lunar base, the giant torus of the future. These are not merely machines but promises, spinning worlds of our own making. In their whirling motion lies the desire to restore weight, direction, and the sensation of belonging. One day, a vast structure may orbit the Moon or Mars, its outer rim turning like a slow heartbeat. Inside, people will walk upright, sleep on horizontal beds, pour water into cups without the droplets floating away. They will feel the subtle pressure on their feet and call it home. The sound of their steps will echo through corridors curved by motion, and they will know that they stand inside an illusion born of science, yet faithful to nature's rhythm. Artificial gravity, in the end, is not simply a technical solution. It is an act of remembrance, a way to bring the Earth with us when we leave it. It acknowledges that gravity is not a prison, but a companion, one that has shaped every cell, every reflex, every dream. In recreating it, we confess that even among the stars, we are never free from the need to feel the ground beneath us. If humanity remains among the stars, gravity itself will become a memory, and evolution will begin again. Every bone, every muscle, every heartbeat on Earth was shaped by the pull of 9.8 meters per second squared. Remove that constant, and the blueprint of the human body begins to drift. What began as adaptation within a single lifetime could, over generations, become transformation. In a world of lesser gravity, bodies would grow taller. Without the weight of their own structure pressing downward, spines would lengthen and bones would stretch thinner and lighter. The human frame would resemble that of a dancer suspended mid-motion, graceful yet fragile. Muscles, no longer built for resistance, would slim and lengthen. The chest might expand to compensate for a slower circulation, while the heart, needing less force to pump blood, could shrink slightly. Eyes would change too. On Mars, where the sunlight filters through thin air and rust-colored dust, vision would adapt to softer hues and dimmer light. Pupils might enlarge, irises darken, and the structures of the retina shift toward heightened sensitivity. Over centuries, children born on Mars could see the faint glimmer of its moons Phobos and Deimos with ease, where Earth-born eyes would see only shadow. Their perception of the world would grow from necessity, evolution's reply to a changed sky. Bone chemistry would alter as well. Calcium, once stockpiled to resist constant pressure, would become less abundant in the skeleton. The marrow might evolve to conserve it differently, producing lighter but more flexible tissue. These Martian descendants would move with an ease that Earth dwellers might find uncanny. Each step a glide, each gesture unburdened by weight. Yet their bodies, so suited for their new home, would find Earth almost unbearable. A return to full gravity could crush joints and strain hearts unused to such demand. The very force that once made them human would become alien. Some scientists speculate that in partial gravity, evolution would favor different proportions entirely. The upper body might strengthen to handle tools and motion in thinner air, while the lower body becomes narrow, used mainly for balance rather than propulsion. The spine could curve differently to support a posture adapted to slow, floating movement. Over long enough time, this could result in a humanity visibly distinct, still recognizable, yet clearly shaped by another world. Even reproduction could change. Embryos developing in reduced gravity would experience altered cellular signaling, as gravity guides how tissues orient themselves. The skeletal and vestibular systems form in part by sensing direction. Without that cue, growth patterns could shift subtly but significantly. The first generations born off Earth might carry within them new geometries of form. If humanity remains scattered among planets, divergence is inevitable. Evolution will not pause simply because intelligence has advanced. It will follow physics, as it always has. Emotionally and culturally, such changes would redefine identity. The people of Mars, born lighter, taller, perhaps more delicate, might look upon Earth with awe, not as home, but as origin. They would speak of gravity as both ancestor and myth, a force that once taught life how to stand. Generations later, they might visit Earth as pilgrims rather than explorers, standing briefly under its full weight before returning to their gentler world. Their bones would ache, their hearts race, but in that struggle, they would glimpse what it means to belong to the original sculptor. For those who remain on Earth, the mirror image would unfold. They would look to the heavens and see versions of themselves evolving elsewhere, shaped by lesser gravity, faster radiation, and thinner air. The species would fragment not through war or distance, but through physics itself. Humanity would become a constellation of adaptations, earthbound, Martian, lunar, each remembering the same origin but tuned to different songs of weight. Gravity, then, would not vanish from the story of life. It would become the thread connecting every form we take. Whether pressing us to the ground or letting us float above it, it will continue to shape who we are and what we might become. In its presence, we found endurance. In its absence, evolution will find imagination. The human form, once sculpted for one world, will learn to belong to many. Proof that gravity, even when gone, remains the quiet architect of all that lives. Every journey into space is also a journey back to Earth. No matter how far humanity drifts, gravity waits. It is patient, constant, unchanging. When the spacecraft begins its descent, the invisible hand that once released the travelers now reaches to reclaim them. The return is not gentle. The body, having forgotten its old companion, meets gravity like a stranger. Re-entry is the first confrontation. The capsule shakes, air ignites around it, and the acceleration presses the astronauts into their seats. After months of weightlessness, the sensation of heaviness feels surreal. Their hearts labor against the rising pressure. Blood rushes downward, pooling in their legs for the first time in months. Breathing grows difficult. The body, which once floated effortlessly, now feels carved from stone. Every organ remembers what it means to be heavy. When the parachutes open and the descent slows, gravity tightens its embrace. The landing itself is brief but violent, a reminder that the planet is solid and indifferent. The moment the hatch opens, the smell of air and soil floods the senses. Astronauts often describe this as overwhelming, like tasting life itself. The first breath of Earth's atmosphere feels thick and living, filled with sound and warmth. The body responds not with joy, but with confusion. Muscles tremble, joints ache, and balance collapses. Standing upright becomes a deliberate act, a test of will against the old familiar weight. Doctors and trainers guide the returning astronauts through the slow ritual of recovery. Every step on solid ground is an experiment in rediscovery. The heart must relearn how to pump against gravity. The veins must tighten. The reflexes must awaken. For days, blood pressure swings wildly. Dizziness lurks behind every movement, and fatigue clings to every breath. The once simple act of walking feels monumental. Yet within this struggle lies triumph, the proof that adaptation works both ways. The same body that learned to live without gravity can also learn to live with it again. Emotionally, the return carries its own gravity. The astronauts who once floated in silence now feel the pull of the planet, not just on their bodies, but on their minds. They speak of being moved by the weight of everything. The ground beneath their feet, the air pressing on their skin, the gravity of human voices, of home. Many describe the first night back as the most profound. Lying in bed, unable to float, they feel the mattress pushing against them, holding them still. That simple pressure becomes a lullaby, a physical memory of belonging. Yet, re-entry brings more than comfort. it brings a renewed awareness of fragility. Every heartbeat under gravity reminds them that life depends on balance between pull and lift, pressure and release. The astronauts often find themselves looking at the sky differently afterward. The stars are no longer distant, they are familiar. The planet beneath them is no longer ordinary. It is miraculous. To feel its pull is to feel life itself. Some never lose the sense of floating. Weeks after landing, they still feel phantom drift when they close their eyes, a ghost of weightlessness lingering in the nervous system. It fades slowly, replaced by the grounding rhythm of Earth's steady pull. In that balance between memory and presence, they discover a deeper truth. Gravity is not an enemy conquered, but a bond renewed. The experience of returning to gravity transforms more than the body. It changes how one sees all of existence. Every movement on Earth, the fall of rain, the bending of trees, the arc of oceans, becomes visible as the language of gravity. It is the same force that carved mountains, shaped rivers, and guided the birth of planets. It is the quiet architect of both motion and stillness. To live under its rule is to participate in the same cosmic order that holds galaxies together. In the end, gravity is more than a force. It is memory. Every bone, every cell, every breath carries its mark. When astronauts return, they do not simply rejoin the planet. They remember it. Their muscles ache with recognition. Their hearts beat in rhythm with its pull, and their minds rest in the knowledge that the struggle against weight is the essence of life itself. For those who have floated beyond Earth, gravity becomes more than physics. It becomes emotion. It is the feeling of homecoming, of belonging to something greater. It is the invisible thread that binds flesh to planet, body to world, humanity to the universe. And so, as the astronauts stand once again beneath the vast sky, the world feels both heavier and lighter than before. The soil beneath their boots is firm, the air thick and real, the heartbeat strong and deliberate. Every step is a reunion with the force that shaped them. Every heartbeat, every breath, every bone remembers gravity. In space, the body forgets, but not forever. Because in the end, gravity is not just what keeps us on Earth, it is what makes us human.